What is a platform orchestrator? How does it work exactly? What difference does it make? Should you consider it when you're building your internal developer platform? Hey, I'm Kaspar from Humanitec, and in this video we'll get a little more technical and speak about what Humanitec's Platform Orchestrator is, how it works, and how it helps you slash your lead time. The Platform Orchestrator is the centerpiece of any modern enterprise-grade internal developer platform. Think of it as a very powerful rules engine that understands what the developers need and serves it based on the configurations and templates provided by the platform engineering team. Humanitec's Platform Orchestrator powers internal developer platforms and self-service setups for many of the best engineering teams in the world. And we early on realized that what almost everybody gets wrong is the orchestration part of their platform. Older platform designs focused on essentially spinning up templated GitHub repositories with varying configuration file formats. Afterwards, the burden to operate and maintain the scripting mess is left to the developers to figure out. When they are overwhelmed, they offload that to the operation teams. As a result, developers slow down, wait for others, and ops has to grind through repetitive tickets. What suffers is the time to market, the lifeblood of any business. In fact, setups that aren't orchestrated show a 30% longer lead time than setups leveraging platform orchestration. In comparison to that, the idea of platform orchestration is to completely reconfigure the entire application and its dependent resources, databases, file storage, compute, or DNS with every single deployment. A platform orchestrator essentially reads a recipe provided by the developers and dynamically creates application and infrastructure configurations with every deployment. This way, there is no difference between the first time a developer spins up a workload and the nth time. The result is a 95% reduction in configuration files you need to maintain and operate. This approach drives an unparalleled degree of standardization and allows platform engineers to build highly scalable golden paths that include all the resources, configurations, and policies by default. Now you have a vague idea what an orchestrator is. Let's get a little more concrete. We first want to clarify where this component sits in your existing toolchain. The simple answer is host CI. It integrates with your build pipeline, so the orchestrator knows when a new image is coming through. You'll also wire it up to your image registry, your secrets managers, and maybe your developer portal and service catalog. While the orchestrator has CD capabilities, you can also integrate a dedicated CD system such as Argo CD. The orchestrator can manage the lifecycle of your infrastructure resources, but can alternatively integrate with any infrastructure control plane. We vaguely understand by now that the orchestrator is about creating app and infrastructure configurations with every Git push, and then deploys and orchestrates the underlying resources. But how does it determine how to create those configurations? The answer is based on the input from two, usually different groups of users. The first group are the developers. They know best what resources their workloads need to run, how the workload connects to those resources, and maybe to other workloads. To describe this, they write a little recipe for every workload. That's called a workload specification. If your workload depends on a database of type Postgres, then that's exactly what you write into your recipe. There's one recipe per workload, so these recipes work across any environment. In other words, they are environment agnostic. And to make it convenient for developers, they're usually simple code files written using the YAML syntax and sit next to your workload source code. Alternatively, you can also describe them using a UI, CLI, or API. That's the first input, but definitely not enough to create final configurations. We know by now that the workload depends on a database of type Postgres. We don't know whether we should wire this workload up to an existing database or create a new one. We don't know how we should create the application configurations. How much compute do we need? Do we need sidecars, labels and annotations? That missing information is supplied by the platform engineering team, our second user group, and not just in time with the deployment. That would be a little slow. It's set in general through baseline configurations. The platform team would, for instance, register and tag all resources you could potentially wire your workload to, and it would define rules for when to use what resource. It would also define baseline application configurations that specify how the final configurations are created. Those baselines are again written as code. So now we have both inputs we need to create the final app and infrastructure configurations with. How does this all connect? The best way to understand this is by really following an entire deployment process from the Git push to the running app. Let's do just that. In the first step, we Git push our workload and our little recipe, the workload specification, and let it run through our CI pipelines. The CI pipelines push the image to the image registry and the recipe to the Platform Orchestrator. The orchestrator receives the information that a new image was built and the path to that image, as well as the recipe itself, and now starts an RMCD execution pattern. RMCD stands for read, match, create, and deploy. In the read phase, the orchestrator reads the recipe, and in our example realizes that the workload depends on a database of type Postgres. In the match phase, it understands the context, for instance, that the deployment is for an environment of type development. And it then figures out what baseline configurations and rules the platform engineering team wants to apply in this situation. In the create phase, the orchestrator creates the application configurations. It then figures out whether to wire the workload to an existing resource or whether it's supposed to create a new one. If it's supposed to create a new one, it can do so using Humanitec's drivers or any infrastructure as code approach. It then fetches the credentials of the resource and injects it through secrets at runtime into the container. In the deploy phase, the workload deploys the workload and we're done. Note that the orchestrator is following this procedure with every single deployment. That means every single time we get new app and infrastructure configurations. That has an incredible impact on the standardization, ease of use and maintainability of your entire setup. What we just described is what we call a golden path. Some developers might feel restricted by this and want to tweak the low-level configurations of the workload in every single resource. If your security posture allows that, that's totally possible. Just give them access to the baseline configuration and they can tweak things to the lowest level. So, how do we get started? Easy. Write the recipe for your workload, plug in the orchestrator at the end of your CI pipeline, configure your baseline configurations, and Git push your first deployment. Thank you for watching this video on how Humanitec's Platform Orchestrator works. If you want to kick the tires, head over to humanitec.com and start your free trial today. If you want us to help you, book a demo with one of our solution architects.